welcome to all the participants, students for this course. A very good morning, good afternoon and good evening to all of you. Welcome to this NPTEL course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sen-Gupta from the IME department at IIT Kanpur. So, as you know, the main points and main bullet points or three areas for this course were averaging techniques and forecasting, multiple linear regression, the second part, and the third one is time series analysis. And we are in the last part, which is time series analysis, and this is the last lecture for this whole course, which is the end of the 12th week, lecture number 60, week number 12. So, what we will cover with all examples and discussions would be the ARCH with parameter P, GARCH PQ and why it is related to ARCH method. We will discuss very briefly about exponential GARCH, autoregressive GARCH and Ljung-Box-Pierce Q-Test, and we will show the results for that for trying to find out the parameters. So, now as I mentioned, show the results means only the main results. So, whatever the coding all part, as I said, I would definitely not go into details, because once you understand the concepts, as I keep saying that, and I am confident that once you understand the concepts, you can easily apply them using the different type of softwares which are available. The autoregressive conditional heteroscedasticity ARCH P process captures the conditional heteroscedasticity of the financial returns, and I said from starting from the 58th lecture, also in 59th and mentioned 2 or 3 times, and also I am mentioning here for the 60th lecture, all the data we are discussing on the time series. Obviously, the question may come, would not all these methods and all these things be applicable for other time series? Answer is yes, they would be, but financial time series has this peculiarity, all these very niceties and all the different models are very nicely applicable for financial time series, also for economic time series. The ARCH process captures the conditional heteroscedasticity of the financial returns by assuming that present conditional variance is the weighted average of the past squared unexpected return. So, here you have how the process is evolving. Over and above that, you are also assuming that the variability is also evolving, and that is why the second bullet point which you see is basically related to the relationship of sigma square suffix t with respect to the average of the past squared unexpected returns which you have. So, what actually you have is, I will try to plot it in the sense mark it accordingly. So, consider this is the data and your actual data also I am plotting as a continuous one rather than a discrete time series. So, the green one is the actual, red one is the predicted. So, what you need to do is find out the difference. So, consider this is epsilon 1, then epsilon 2, epsilon 3, epsilon 4, square them up and add them. So, I am taking 4. So, that would basically dictate the variability of the process. So, the past difference between the actual and the predicted, square them up, and as you multiply them, I have added them, but as you add them up, here I am considering the parameters as 1, but if you consider the equation which is written in the slide 107, the parameters of the fixed values are considered as alpha naught, alpha 1 till alpha p, and p, if you remember, is the parameter of the ARCH method. So, let me again read it. We assume that the present conditional variance, because condition on how the fact this whole process has evolved, is basically the weighted average of the past square unexpected returns. So, the different squares. and the weights are alpha 1 to alpha p, all are greater than or equal to 0, and obviously alpha naught is greater than 0, which is a constant. The GARCH PQ model adds the extra concept of Q autoregressive terms to the ARCH method. So, in the ARIMA one, if you remember, we had the autoregressive one plus the moving average one. Now, in the GARCH you have basically the concept, the Q being the autoregressive one which is there, but along with that the other concept of conditional heteroscedasticity is being there, moving average is not there. So, main emphasis from the concept of ARIMA is, rather than paying attention to the moving average, you are now shifting your attention to the variability. That means, from the first moment to the second moment. Again I am repeating, for the ARIMA it was autoregression plus the moving average. In GARCH it is basically conditional, the autoregression plus the conditional heteroscedasticity based on the variability, because variability is very important. We kept saying time and again for the time series for the financial one or the economic data point. So, the conditional variance takes the form which I had mentioned is, the first part is what we have just mentioned. I will highlight it. So, this is the first part, be it on autoregression, on this concept of conditional variance, and the second part is the autoregressive component. I should mark it with the different color, sorry, my mistake. So, the blue one coming from autoregression and the green one from conditional heteroscedasticity. Also here, as usual, the concept of beta 1 to beta q are greater than or equal to 0, and obviously that error corrective coefficients are there. High values means volatility reacts quite intensely to the market movements, and beta means the lag coefficient, high value correspond to persistency of the volatility, and the effect continues for a longer time. So, EGARCH, exponential GARCH, AGARCH, autocorrelative GARCH captures leverage effects very well. High presence of asymmetry in volatility clustering is there in financial markets, as we have seen in the data. So, the EGARCH means the conditional variance takes now the form of log of that rather than the sigma square. So, you have the terms have log of the conditional variance, obviously alpha naught is there. The second part which you had was basically based on the concept of autoregressive, that is being considered as it was without the log, there you have the logarithmic terms, and this value of the function g is basically the standard normal variate of z, which is the standardized unexpected return which you have based on epsilon t. If you remember, the epsilon t, or in many cases is denoted by E, is the difference between the actual data and the real data with the suffix t based on which you are measuring. So, this is basically the concept of conditional variance taking the form for the EGARCH. Now, for the AGARCH autoregressive GARCH model of 1 1, by the way 1 1 means basically the parameters of p and q. So, if p is more than 1, q is more than 1, the terms will increase, that is just the factor. So, here sigma square, which is conditional heteroscedastic concept or the variability, is basically given by a leverage coefficient which is you are considering. So, difference between the unexpected error term and the leverage coefficient we are considering constant, but it can change also and depend on time. We are not making things complicated. Plus the other factor is the idea which you have the autoregressive term, which is also already there in the ARCH method. So, here remember the ARCH method is considering the parameter as q, but initially we had considered as p, just to make the difference obvious I am mentioning that. It is easiest to estimate as compared to EGARCH method, the AGARCH method, and volatility forecast made from AGARCH model differ from that being made by the GARCH model, because autoregression part is much more prominent in AGARCH. So, and if you go into the analysis and the estimation of the GARCH model, choice of data is important, stability of the GARCH parameters need to be found out, and we will come to that, and also the concept of long term volatility, how stable they are, and obviously for time series for financial data, this is a problem. In choosing time span of the data, which is important, a view has to be taken as to what is the time frame based on which you are considering. So, what are the events which is affecting? So, example, if you consider the financial shocks or the Gulf War or the petroleum price suddenly fluctuating, that or the crude price fluctuating can have huge spikes. So, that may affect the actual prediction based on which you are trying to do, hence we should be careful about the data span. All parameter estimates, in particular for the GARCH constant, are very sensitive to the historical data used from the model. So, one fit for all GARCH model with the same parameters may not be possible for throughout the time series, considering the DAX data we are considering. Long term levels of volatility to which a current volatility term structure will converge will depend on the estimates of the GARCH model parameters and how robust they are able to predict the volatility and to what the level we are able to find out the best parameters. So, that will give us much more confident. Model should capture volatility clustering adequately depending on the data set we are taking and the time frame, as I mentioned in the last slide 111. Return should have no significant auto-regressive conditional heteroscedasticity once they have been standardized by their conditional volatility concept. So, that mean averaging technique, or if you are considering the first difference, second difference. So, once this is done, auto-regressive conditional heteroscedasticity should not be there that much, because if it is there, then the readings would not be actually as we want. So, if I consider a data set, I am just giving the results. So, this type of data set, whatever data set you have for, especially for the Bajaj data which is there in the Excel sheet, or the DAX data which you have in the Excel sheet, all will give you the similar type of results if you run. For the GARCH 2.1, P2 Q1 and EGARCH P11, if we consider the GARCH model. So, if I consider the concept of squared standardized error for both of them, the EGARCH method is much better, because the squared error limits are much more better, because the squared means the difference between the actual error and the actual value and the predicted value, which you are considering as epsilon. In many cases, we do consider as E. Why I mentioned E is that in the regression models, if you have considered epsilon as the error, E was the sample component or the counterpart. Analysis of estimation in GARCH 1.1 model. The pre-estimation analysis loads the data in the form of price series. Then you convert the price series to the return series, which is there in DAX. So, you have the price, you have the log return, and you check the returns for the correlation and quantify the correlations accordingly. And once the parameter estimation is done, as we have found out using this BIC, AIC and other concepts by using the log likelihood concept MLE methods and all the algorithms which are there, you post estimation of the analysis is done. This part of the example actually starts by comparing the residuals and the conditional standard deviations and the returns, and compare them. Then it uses the plots and quantitative techniques to compare the correlation of the standardized innovations which are there. So, if I consider the price variation and the return variation for our time series data. So, if you see for 2006, the data is quite contrasting. From February 2006 to August, it is manageable, then it again shoots up. But if I consider the return series, they give us a total different picture. So, obviously, you have to basically do all the autoregressive studies in order to see the fact that heteroscedasticity and all these properties are well taken care. If I do these autocorrelation function for the bounds for the raw returns and autocorrelation function for the square returns, so that will give us a good idea about where the square returns are and how robust or how good they would be in order to basically find out the concept of auto correlation concepts and auto regression parameters, and what is the relationship, to what degree they are present. So, one good test is this Ljung-Box-Pierce Q-Test. It can be verified at least approximately that no significant correlation is present for real raw data when tested, say for example, for lags of 10, 15, 20, so on and so forth, at a value of 0.05 level of significance. However, there is a significant serial correlation in the square returns when tested with the same inputs, and we will check that. So, consider for the DAX data, I am taking the actual DAX data from January 2025 to 19 June. We have, when we run this test, the values of P, Q statistic and the critical value is there. What is important is the null hypothesis is rejected, which is significant autocorrelation is detected for the actual data for a lag of 1. When I run, so and this critical value Q statistics can be changed accordingly. When I run for the logarithmic of that, obviously other things are important. What is important, most important is the null hypothesis is not rejected, that is not no significant autocorrelation is detected. So, we are much more certain the logarithmic prices would be much better in order to run the models accordingly. So, consider another example. We are taking the GARCH 1 variability Armax conditional probability distribution is Gaussian is taken, number of model parameter is taken 4, and based on that we generate it. So, for the error terms are very significant, and the one error term is basically about 66 into 10 to the power minus 5, and the GARCH 1 and the ARCH 1 parameters are coming as 0.92801 and 0.047, with an error of for both of them being respectively 0.047 and 0.029. Now, what is more significant is that for the GARCH model with a parameter P as 1, the value is about 0.924, but for the ARCH one it is very less. So, considering the concept of autocorrelation, how you can basically model it, and here it is. The first part is the constant, which is almost, I should use a different color, sorry. So, this is the k value which you have, which is 2.83 into the power minus 6, it can be ignored. So, this is sigma square is basically the error term variance. So, that depends on the concept of this dependent error. Dependent error means basically I am saying the actual value minus the predicted value for the past and square them up, and this sigma square t minus 1 is the past data. So, if I consider them, the value of the past data is about 0.92, while for the difference from the actual data and the predicted data is about 0.047, which auto regressive part concept for the ideas based on regressive model, auto regressive model is not that significant. So, if I plot it comparing the residuals, conditional standard deviation and the returns for are given as this, and the results which I saw which was shown, that with respect to the diagram would make much better sense. So, the diagrams and all these things, once you learn these models, I know, again I am saying I know there are a lot of concepts which I am going through, but at least it should give you a better idea that how you can tackle and understand the output. So, this is the correlation and standard innovations. So, if you compare the autocorrelation function for the squared standard innovation in this figure to the ACF for the squared returns prior to defeating the default model, it will show that the default model sufficiently explains the heteroscedasticity in the raw data. So, the raw data has to be normalized in whatever, like taking the first difference, second difference, or the average mean difference, and so on and so forth. I am talking about the raw data. So, for the EGARCH model, when we run it, the autocorrelation function for the squared standardized error is quite nice. So, there is much less fluctuation than the concept or autocorrelation function when you use the other models GARCH or EGARCH model. So, application of GARCH models are used to generate volatility term structure that converts to long term average volatility levels. Term structure forecast mean revert to long term values of the volatility. Major difference between the forecast made by GARCH and AGARCH are in short term volatility forecast following a large fall in the market, or it can be large increase in the market also. So, applications of the GARCH models are there in option pricing, smile fitting. So, they are used in Black-Scholes model, and the GARCH implied volatility is utilized very heavily in Black-Scholes model. So, with this I will end this whole set of series of lectures for this course on NPTEL, which consists of 3 parts. One was basically the forecasting, second was the regression, third is the time series. I know the time series, again I am saying the time series part is much more in depth. We may not be able to cover all the models, but at least given the ideas that what does P mean, Q mean, what is ARCH, GARCH and ARIMA model and ARMA model, I am sure people who are interested can pick up the nuances and definitely go into much more depth in these studies. Any queries which are there, obviously that our TAs are helping you all out, and any specific queries any students or participant have, they can definitely write to me directly to my official email. I am sure I will be able to help them out accordingly. Thank you very much and have a nice day.